Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 1210, Introduction to the Sky and Solar System, Lecture 32, Mars. So as we continue our tour of the solar system, the next planet that we will study is the planet Mars. As we've done before, let's start with some basic facts about Mars. Its average distance from the Sun is 1.52 astronomical units, and its orbital period is 1.8 years, about 687 days. Its orbit is not inclined very much with respect to the Earth's orbit around the Sun. It's only 1.85 degrees, but it is in a much more eccentric orbit than the Earth. Its orbital eccentricity is 0.093. And Mercury had the largest eccentricity of any of the terrestrial planets, and Mars has the second highest eccentricity of the terrestrial planets. You'll remember that the orbital eccentricity for the Earth was 0.0167. The diameter of Mars is about half the diameter of the Earth, and its mass is only about 10% the mass of the Earth. Its average density is a little less than 4 grams per cubic centimeter, and its rotation period is almost the same as the Earth's. A solar day, which means from noon to noon or sunrise to sunrise on Mars, is 24 hours, 39 minutes, and 35 seconds. So someday when humans colonize Mars, they won't have to adapt to a day that is significantly different than ours. Well, let's start with some past history of Mars, and probably one of the most famous things that people are familiar with when it comes to the history of Mars is the story of the canals, or at least the belief that there are canals on Mars. So the first question I have for you today is a learning catalytics question, and that question is, the canals on Mars are the work of an intelligent civilization, true or false? So go out to Learning Catalytics, take about 10 seconds to answer this question, and then come right back. Okay, so what do you think of the answer to this one? It's a bit of a trick question because although astronomers in the past, at least a couple astronomers in the past, thought they saw canals on Mars, there's no evidence that the canals actually exist. Today, when the Hubble Space Telescope photographs Mars, you don't see any evidence of the canals. And in particular, with all of the spacecraft we have orbiting Mars, taking high-resolution images of the surface, we now know for certain that the canals on Mars were an optical illusion. The canals actually came about because in 1877, an Italian astronomer by the name of Giovanni Schiaparelli reported that he could see thin, faint, straight lines that connected dark regions on the surface of Mars, and he used the Italian word canale to describe the lines. So the question is, after this, what did most astronomers think? Did most astronomers in the late 19th and early 20th centuries believe that there were canals on Mars due to an intelligent civilization? So go out to Learning Catalytics. This is more of an opinion question than anything else. So what do you think? After Giovanni Schiaparelli discovers these canali on Mars, what do most astronomers make of this? All right, so what did astronomers make of Schiaparelli's discovery? Well, one astronomer in particular became quite famous over this, and that's the American Percival Lowell. Percival Lowell was not trained as an astronomer. He came from the Lowells of Massachusetts, who made their money in the fabric business and the weaving business. But Lowell's family was wealthy. It allowed him to pursue whatever he wanted in life, and one of those things was astronomy. So Percival Lowell built himself a giant observatory in Flagstaff, Arizona, and equipped it with a state-of-the-art telescope, specifically that he could study these canali that Schiaparelli had discovered on Mars. Because he believed that these canali, he thought the word meant canals, were literally canals that were built by an intelligent species to funnel water from the poles of Mars to a dry equator. Well, Percival Lowell believed that he could see the canali on Mars, and he mapped them out and he popularized them in books and lectures. These books were written for the general public, and so the canali became ensconced in the general public's understanding of Mars. Lowell believed that the features changed with the seasons, He could see dark markings on the surface that would change year after year after year, and he thought this was changing due to crops growing and being harvested on the surface of Mars. But the thing is, the majority of astronomers could not definitively confirm the canals. They were skeptical of the existence of the canals, and they really felt that claims of intelligent extraterrestrial civilizations living on Mars were really just exaggerated conjecture. They believed that Mars would be too cold to have life on it. But this popular belief in the canals on Mars, it persisted all the way until 1965. But with the first flyby of Mars with the Mariner 4 spacecraft in July of 1965, Mars was revealed to be a frozen desert-like surface, frozen desert-like planet with no evidence of plant life down on the surface. So that was the surface of Mars revealed by Mariner 4 back in 1965. Mariner 4 also discovered that Mars has an extremely thin atmosphere to it. Today, when we photograph Mars with the spacecraft that we have in orbit around Mars, we see that it confirms what we discovered in 1965, that Mars is a cold, dry planet that has a very, very thin atmosphere. Now, there are lots of interesting features on Mars. There are dark regions that you can see even through a small telescope. There are lots and lots of craters on Mars that are only really visible by spacecraft. They're not visible from here on Earth. But from Earth, even with a small telescope, probably the most common feature that you can see on Mars are the polar caps. On Mars, there are both a north and a south polar cap, and those north and south polar caps change with the seasons. You can actually watch the polar caps growing and shrinking on Mars, just as they grow and shrink on the Earth. You might remember from earlier in the semester when we were studying the seasons, it was mentioned that Mars is tilted over by about 25 degrees, which is almost the same that the Earth is tilted over. And that means that Mars goes through seasons very much like the Earth goes through seasons. The one difference is that Mars' orbit is so eccentric around the sun, or at least much more eccentric than the Earth's orbit around the sun, that distance does make a difference for Mars. And on Mars, the southern hemisphere's seasons are far more extreme than the northern hemisphere's seasons, because Mars is at its closest to the sun when the southern hemisphere is tilted towards the sun, and then half a Martian orbit later, when the sun is now tilted towards when the northern hemisphere is tilted towards the sun, Mars is at its furthest from the sun. And Mariner 4 discovered that Mars has a thin atmosphere. As we saw in the lecture on atmospheres, the pressure of the Martian atmosphere is only 0.7% of the atmospheric pressure here on Earth, and that's equivalent on Earth to an altitude of 110,000 feet. And you're probably familiar with the fact that most people have a hard time breathing when they get up to around 12 or 13,000 feet. By 14,000 feet, most people are breathing really hard. Above 18,000 feet, you can't survive for very long. The tallest mountains on Earth are 29,000 feet. Up where commercial airliners fly from sort of 30 to 45,000 feet. If the airplane depressurizes, you'll lose consciousness in just a few seconds. And on Mars, the atmosphere is so thin it's equivalent to 110,000 feet on Earth. So the atmosphere is incredibly thin. It's also 95% carbon dioxide, which means even if it wasn't that thin, a human could not survive on Mars without a spacesuit. Now, the Martian atmosphere is too thin for liquid water to exist on the surface. If you were to take a cup of water to Mars and open the top off the cup would immediately boil away because the atmospheric pressure is so low. So liquid water can't exist on the surface or it'll quickly boil away. We'll see later on that there is some evidence that liquid water might drip on the surface, and the best evidence we have as to why that water can be liquid is because it is combined with salt to make a very briny solution. And as you're familiar with here on Earth, combining salt and water can greatly reduce the freezing point of water. The winds on Mars can be tremendously strong, and they can generate monstrous dust storms. About once every decade or so, Mars goes through a period where it has a planet-wide dust storm. The last one was in 2018. Here is Mars in May of 2018, where you can see lots of features on the surface. And here it is on July 1st, 2018. And you can see almost no features on the surface because of this planet-wide dust storm. This is the dust storm in 2018, as we'll learn in the next lecture, that caused the demise of the Opportunity rover on the surface of Mars. The dust was so thick that the sunlight could not get down and power the solar panels that were on top of the rover, and the rover ran its battery down and died. Well, earlier we had talked about the fact that the surface of the moon consists of two types of terrain. The surface of Mars, we're going to simplify it to three types of terrain. The Mars consists of the southern highlands. Like the highlands on the moon, they are higher than the average altitude of land on the surface of Mars, and they are also completely covered in craters. As you can see, there are areas with craters on top of craters on top of craters. Hellas here is a giant impact basin on the surface of Mars. The second region on Mars are the northern lowlands, and the northern lowlands are much smoother. They have far fewer craters than the southern highlands do, and so those are the northern lowlands. And the third region on Mars that we're going to talk about is this giant bulge right here called the Tharsis Bulge. As we'll find out, the Tharsis Bulge is a huge volcanic bulge on the surface of Mars, pushed up by lava flowing across the surface. So the three types of terrain are the southern highlands, the northern lowlands, and this Tharsis Bulge. So in learning catalytics, go ahead and answer this question. Which is older, the southern highlands or the northern lowlands? Remember how scientists tell how old terrain is. Think back to our lecture on the moon. And I want you to look at that image of Mars and look at the southern highlands and look at the northern lowlands and go out to learning catalytics and tell me which is older, the southern highlands or the northern lowlands. Well, hopefully you remember from our lecture on the moon that scientists can count the number of craters per square mile or craters per square kilometer, and that will tell you how old a surface is because that tells you how long it has been exposed to space. And so you'll notice that the southern highlands on Mars are completely covered in craters. The northern lowlands have significantly fewer craters than the southern highlands do. And so the southern highlands must be older than the northern lowlands. Something has happened to the northern lowlands to cover over all the craters or to erase all the craters that were made during the late heavy bombardment. You will remember that on our moon, the vast majority of craters in the highlands date back to around the time of the late heavy bombardment, this time when the solar system was clearing itself out and thousands upon thousands of comets and asteroids were colliding with the terrestrial planets. The same was going on Mars, and that's what we see written here in the southern highlands. But since then, something has happened to the northern lowlands, and that the northern lowlands are younger than the southern highlands. So now go ahead and answer this question in learning catalytics. Which is older, the southern highlands or the Tharsis Bulge? So now look back at that map and see if you can figure out which is older, the southern highlands or the Tharsis Bulge. The Tharsis Bulge is this region right here that's marked with the words Tharsis volcanoes. So which is older? Okay, the same logic applies here that applied just a few seconds ago. When we look at the Tharsis Bulge, we can see hardly any impact craters on it at all. When we look at the southern highlands, we see that they're covered in impact craters. And so this is another case where the southern highlands are older and the Tharsis Bulge is younger. A really interesting question is which is younger, the Tharsis volcanoes or the northern lowlands, because just on this image we can't tell by looking at the cratering. So that would require looking at these volcanic flows, that they flow out on top of the northern lowlands or did the northern lowlands come up and encroach on them? And that's not clear. There's evidence that they're probably contemporaneous, that the Tharsis volcanoes and the northern lowlands are being created at about the same time on Mars. One hypothesis is that the northern lowlands actually represent what used to be a giant ocean on Mars. It is along the boundary between the northern lowlands and the Tharsis Bulge over here and the southern highlands. It is along this boundary where we see lots of evidence that water used to flow on the surface of Mars. And so this boundary is a great place to look for evidence of past water on the surface of Mars. And it might be that we see water flowing into what used to be a planet-wide ocean in the northern lowlands. Well, let's talk about that Tharsis Bulge for a second, because that's so fascinating. Mars is home to a number of significant volcanoes, and one of them is Olympus Mons. Olympus Mons is the largest volcano anywhere in the solar system. It's got a diameter of 500 kilometers and a height of 25 kilometers, and its volume is about 100 times greater than the largest volcano on Earth, which is Mauna Loa in Hawaii. The first thing to know is for Mauna Loa in Hawaii, it is the largest volcano on Earth, but only about half of it is sticking up above the water. More than half of its height is actually below the ocean surface. And Mauna Loa is so heavy that its weight is pushing down on the crust of the Earth, and it's actually sitting inside of a moat. Around Mauna Loa is actually a depressed region that comes from the weight of that giant volcano depressing the Earth's crust. Compared to scale, here is Olympus Mons, the largest volcano in the solar system. And we can see that it is monstrously huge compared to Mauna Loa. As I said, it's the largest volcano in the solar system. In fact, to put it in perspective, here is Olympus Mons and more of the Tharsis volcanoes. And you will notice the size of these volcanoes compared to states in the United States. Again, they're monstrously huge. Olympus Mons is about the size of Washington State and half of Oregon State put together. Now compare that to mountains like Mount Rainier and Mount St. Helens and Mount Hood, all of which are up here in the Cascades, and think about how small they are compared to a giant mountain like Olympus Mons. And keep in mind, although it is the biggest, that the other Tharsis volcanoes are significantly large as well. Half the size of Iowa, half the size of Colorado. So the Tharsis volcanoes are very large. So looking back on these, what do you think they are? Is Olympus Mons a composite stratovolcano, or is it a shield volcano? What do you think? So look at the evidence. Here's a picture of it. So is Olympus Mons a stratovolcano, a composite stratovolcano, or is it a shield volcano? Go out to Learning Catalytics and answer that question. So what do you think on this one? Well, the way to tell on this one is to look at this diagram at the top up here. And this diagram will help you figure out whether it's a shield volcano, because remember, shield volcanoes, they can be very tall, but they're very, very broad. And composite volcanoes tend to have the very steep sides. And your first thought might be to look at this and say, well, this one has very steep sides on it. But here's the thing. We know that Mauna Loa is also a shield volcano, and in this diagram, it too looks like it has steep sides. And that's because the author of this diagram decided to exaggerate the vertical scale. You'll notice the horizontal scale here, that's 100 kilometers, and on the vertical scale, that's 10 kilometers. And what that means is they have exaggerated the vertical scale here. Olympus Mons is actually a giant shield volcano made up of basaltic lava flows, and it is very, very broad. It's very tall, but also very, very broad. So Olympus Mons is a giant shield volcano. Now, as all these volcanoes on the Tharsis Bulge were being pushed up, it was pushing out the crust of Mars. And as it pushed out the crust of Mars, it generated a giant crack in the surface of Mars that we call Valles Marineris. Valles Marineris, or Mariner Valley, is named after one of the Mariner spacecraft that went and studied Mars. Now, Valles Marineris is not a canyon like we have on Earth. So here's a picture of the Grand Canyon, which you know was cut by running water. If you look down here, you can see a little bit of the muddy Colorado River down there. So the Grand Canyon was cut over hundreds of millions of years by water running across the surface of the earth. Valles Marineris was not cut in the same way. This is a fault that is due to the expansion of the crust of Mars, probably as the Tharsis volcanoes were pushed up. As the volcanoes were pushed up, the surface of Mars had to spread apart, and the resulting cracking is what we see today as Valles Marineris. Now, it's hard to put Valles Marineris in its scale here. If you look at the Mars, it looks like it stretches all the way across Mars. To put it in a better scale, here are some numbers. It's about 4,000 kilometers across at the surface. It's about 600 kilometers wide, and it's about 8 kilometers deep. And that's 4 times deeper than the Grand Canyon. This is a picture of what Valles Marineris looks like compared to the continental United States. So the west side of Valles Marineris would be in Los Angeles, and the east side of Valles Marineris would be over here on the east coast of the United States. And so Valles Marineris would stretch, if it were here on Earth, it would stretch all the way across the United States. Now, since it's been created, it's been modified by erosion, landslides, possibly some running water over time. But keep in mind that the canyon was not cut by running water. It is, in fact, some kind of large tectonic fault, probably created when magma pushed up the Tharsis Bulge or the Tharsis Rise. Now, this does raise the interesting question of water on Mars. Orbiting spacecraft have revealed many flow features on the surface of Mars. Some of them resemble meandering rivers like this. So these are an example of outflow features, outflow channels on the surface of Mars. We would call them on Earth dendritic channels because they look just like the branches on a tree. But you can imagine what happened here. Something was flowing on the surface of Mars, and as the flow in these little streams gathered into bigger streams, they gathered into even bigger streams, and then they flowed out into a low-lying area down here, just like happens on Earth. So this is an example of evidence that there was once flowing water on Mars. We don't know whether these particular outflow channels came from rain coming down. These channels seem to be less developed than drainage channels on Earth, so it's more likely that what we're seeing here is the draining of groundwater rather than the draining of rain. But clearly it was water draining on the surface. We see evidence of catastrophic water flows on the surface of Mars. This is Ophir Chasma, which is actually in Valles Marineris. It's on the north side of Valles Marineris. And it's a place where there was a landslide, which is not unusual. But what is unusual is that when this land slid, it flowed down this outflow channel and flowed for a very long distance. This is evidence that this soil was saturated with water, because soil will not normally flow like this, or sand will not normally flow like this. This was clearly soil that was mixed with some kind of water. And then finally, we see evidence for catastrophic floods on the surface of Mars. Here's an example of a region on Mars that had a catastrophic flood come through. These teardrop-shaped islands like this are exactly what we see on Earth when water encounters an obstacle of some kind. It leaves behind a teardrop-shaped island. So that raises an interesting question. From this diagram, you can actually figure out which is older, this crater here or the teardrop-shaped island. So which one is older? Is the island older or is the crater older? So go ahead and take about 10 seconds to answer this one in Learning Catalytics. All right, so what do you think on this one? Well, I think the answer to this one is that A, the crater has to be the older of the two. It would be quite a coincidence if the crater just happened to land on the end of that island. But more importantly, teardrop-shaped islands like this form when flowing water encounters an obstacle. And in this case, the crater was created first, and then the flowing water came second, and it encountered the crater, and it had to flow around the rim of the crater. And as it flowed around the rim of the crater, it made this teardrop-shaped island. In fact, the same thing happened up here. This crater right here, that one as well. This one certainly existed before the flood came, and the flood waters wrapped around the island that was already there. So, examples of catastrophic floods on Mars. Well, water on Mars raises some really interesting questions, and these are the questions that are driving our current exploration of Mars. So the questions are, how long did the water flow on the surface? Where did the water flow to? Did it ever pool on the surface, and for how long did it pool? And that's really important because of questions about the origin of life. Life requires water to survive, but it's not just flowing water that's only flowing for a day or a week or even a few months. Water will have to pool on the surface for millions or tens of millions or hundreds of millions of years for life to form. So the question is, how long did the water pool on the surface of Mars? Did it pool long enough that life may have evolved on the red planet? The next question is, where did all the water go? Mars today is an extremely dry planet. Now, some of the water is locked up in the polar caps. Some of the water is probably frozen underneath the ground as permafrost. But overall, there appears to have been significantly more water on Mars in the past than there is today. Where did that water go? And then, if water did pool on Mars, the major question is, did life develop on Mars? And we're not talking necessarily about macroscopic life like animals or plants. At least from the spacecraft and the rovers that we've sent there so far, it seems quite clear that complex life did not develop on Mars. But the question is, did simple bacterial life develop on Mars? Could algae have developed on Mars, or a Martian version of algae? And then, if life did develop on Mars, could it still be there today? Could there be pockets on Mars where liquid water still exists and life is somehow still holding on? And so, as I said, these are the questions that are driving the current missions to Mars, and we're going to see those in our next lecture. But for right now, let's talk about these last two questions. This last question in particular: was there life on Mars in the past? And is there life on Mars today? So let's consider life on Mars in the past. You may have heard that there may have been a discovery of fossil evidence for life on Mars. In 1996, a Dr. David McKay at the Johnson Space Flight Center in Houston, Texas, and the group of scientists that works with David McKay claimed that a meteorite that had been found in Antarctica had chemical and physical evidence for past life on Mars. So this is a photograph of the meteorite. So first of all, Antarctica is a great place to go look for meteorites, and the reason is twofold. First of all, in a lot of places in Antarctica, you can drive across huge sheets of ice. And if there are rocks sitting on top of the ice, those rocks are far more likely to have come from above than to have tunneled up from underneath the ice. So in many of these places where meteorites are found on the surface, they're found by literally driving snowmobiles across these giant ice sheets looking for rocks sitting on the surface. There are other places in Antarctica where the way that the ice moves tends to funnel vast quantities of ice into small areas, and then as that ice disappears, any rocks that were trapped in that, which are mostly going to be meteorites, will get deposited, and they're great areas to go look for meteorites. So in 1984, that's where the 84, this is a meteorite, ALH 84001. So this came from the Allen Hills region of Antarctica from the expedition in 1984 that went to go look for meteorites on the surface of Mars, and it's specimen number 001. So this is what the meteorite looks like. So first of all, no one doubts it's a meteorite. It's got this dark black crust on it, and that's called the fusion crust. And that fusion crust comes from the heat of entry through the atmosphere. It gets so hot that the outer layers of the rock actually melt. What's also not in dispute is that it's an ancient volcanic rock, about 4.5 billion years old. And it is very likely that this ancient volcanic meteorite came from Mars. And the reason for that is there are gas pockets trapped inside the rock. And the gas in those gas pockets have the same composition as the atmosphere on Mars today. And so that makes it very likely that what we are looking at is an ancient piece of Mars that was literally blasted off the surface of Mars, wandered around the solar system for billions of years, or at least millions of years, wandered around the solar system before crashing down to Earth. So what is the evidence that this rock may have contained life in the past? The first thing is there are little globules of carbonates that are inside fractures in the rock. And those carbonate globules indicate that water percolated through the rock at some point in its past history. Now, from what we can tell, the rock has not been on Earth long enough to have been exposed to liquid water. So in principle, this liquid water would have to have happened while the rock was on Mars. But those are carbonate globules and fractures on the rock. There are organic molecules inside the rock, polyaromatic hydrocarbons and amino acids, and they're found around the carbonate globules, and they might indicate that not only did Mars have water in the past, but that water had the organic building blocks of life. Probably most spectacularly, and the thing that certainly got the most press, was that electron microscope photographs taken of the inside of the rock showed very peculiar microbe-like structures, and these were believed to be what are called microfossils. We're used to the idea that animals that have hard shells or hard bones can be fossilized, right? When we dig up the bones of a dinosaur, we're seeing the hard bones. Most of the soft flesh does not fossilize, but most of the bones do. When the conditions are just right, even the softer body parts can fossilize. And in some cases on Earth, we have discovered fossils of what we believe to be ancient bacteria. That is true, little tiny fossils inside of rocks that might have been ancient bacteria. So these peculiar microbe-like structures that appear in the rock may be an indicator that they are fossils of ancient life. And then finally, there are chains of iron-bearing hematite minerals. Hematite is an iron-related mineral. And these chains of iron-bearing minerals are similar to those found in rocks contaminated by bacteria here on Earth. The problem with this is that lots of other scientists claim that each of these pieces of evidence, taken separately, can be explained by ordinary chemical and geological processes, and they don't necessarily require that there was life on the Mars in the past. For example, take those fossils for a second. They sure look like fossilized bacteria with one problem. These fossils are tiny compared to bacteria on Earth. They're much, much smaller than the smallest bacteria found on Earth. And it's hard to understand, with these being this small, how you can pack everything into one of those living cells that a cell needs to survive. As I said, they're much, much smaller than bacteria, than the simplest bacteria here on Earth. So that makes them unlikely to be bacteria simply because they just don't have the volume to them that would be required to have all the machinery that's required to keep a cell alive. And altogether, taking all the results, the vast majority of scientists are skeptical that David MacKay and his colleagues discovered evidence for past life on Mars. All put together, it is an intriguing result. But as I said, each one taken independently can be explained by geologic processes that do not require the presence of past life on Mars. I think we won't be able to answer this question definitively until we send spacecraft to Mars that can bring samples back to Earth. And it may not be until we send humans to Mars that we conclusively determine whether there was once a bacterial life, unintelligent life on Mars at some point in the distant past. Now, you might be wondering, hey, wait a second. Wasn't there intelligent life on Mars in the past? Other than the canals, you've probably heard of the case of the famous human face or face on Mars. So the face on Mars is, I would argue, a made-up controversy. The Viking orbiters back in, they arrived at Mars in 1976, took a photograph of a hill on Mars, and some people believe that that hill looked remarkably like a human face. Now, here's the thing to know about human beings. From the moment we're born, and I mean this literally, from the moment we are born, we look to human faces. We try and find human faces. We look at human faces. A baby does a tremendous amount of learning by watching the faces of its parents and guardians. That's how babies determine whether they should be scared, whether they should be happy. There's a lot of communication that goes on just from looking at faces, a lot of expressions. That's why people make exaggerated expressions around babies. We are biologically hardwired to look for evidence of human faces. So it's not surprising to me that people will occasionally pop a piece of toast in the toaster and it will come out with the face of Jesus on it, or that they will see a rock formation on the surface of Mars and they will see what looks like a human face. The thing is, this rock formation has since been photographed by spacecraft in orbit around Mars that can take really high resolution images of the surface. And what we see is that these rocks on Mars are nothing more than just a hill. They don't look to me to be evidence of an intelligent civilization. But I'm curious as to what you think. Do you think that the face on Mars is a monument built by an intelligent civilization on Mars or not? So true or false, the face on Mars is a monument built by an intelligent civilization. All right, I'm curious to know what you thought. I'll be curious to see the answer to this question. Here is the best image we have of the face on Mars as to what it looks like. This was taken by spacecraft that now are much more capable than the old Viking orbiters. They can take much higher resolution images. And now that we look at it, to me, it doesn't look like much of a face at all. I can see where the resemblance comes from. This might be the nose right here. You've got eyes up here, not much of a mouth down there, but it clearly to me looks much more like a hill than it looks like a face. In any case, you might wonder, what does this tell us about what the Martians on Mars might look like? And the answer is, I don't think they look very human-like. So going back to science fiction, I think they look a lot more like the apes from the Planet of the Apes. So maybe that's what the Martians looked like. There is a three-dimensional rendering of the face on Mars if you're curious as to what the hill looks like in 3 dimensions. I don't believe that the face on Mars is evidence of an intelligent civilization in the past on Mars. I think there's lots of reasons to believe that Mars was not wet enough, long enough for not only life to develop, but for an intelligent civilization to develop. I just don't believe that's true. And I also believe that the far simpler explanation for this is simply a hill that has, when the lighting conditions are just right, some passing resemblance to a face. Right, and that's not unusual. Here on Earth, some of you might be familiar with the Man in the Mountain. Up in New England, there was a rock formation that looked remarkably like the face of a man called the Man in the Mountain. And just a few years ago, actually, it crumbled off the side of the mountain and was lost. But again, it was one of those rock formations that when you look at it, because of our propensity, the fact that we're hardwired to look for faces, you look at this rock formation and it looked remarkably like a human face. Now, let's spend a few minutes talking about the moons of Mars. Mars has 2 moons, Phobos and Deimos. As you'll remember, Mars is the god of war, and Phobos and Deimos are the 2 companions to the god of war, and they are fear and panic. So the 2 Martian moons, as we'll see in a minute, are probably captured asteroids. Both of them are very small. Phobos is only 23 kilometers in diameter, and Deimos is only 13 kilometers in diameter. So to put that in perspective, with a diameter of 23 kilometers, here we're talking, about 16 miles or so in diameter, and here we're talking probably about, probably 8 or 9 miles in diameter, so very much smaller. So these moons are tiny compared to our moon or the big moons of the outer solar system. Phobos is only 9,400 kilometers from the surface of Mars. Deimos is about 23,500 kilometers. Remember, by comparison, our moon is 384,000 kilometers from the Earth. So these are significantly closer to Mars than our moon is to the Earth. Phobos goes around Mars in just a third of a day, in about 8 hours, and Deimos takes about 1.125 days to go around Mars. So here's what Phobos looks like. Phobos is an incredibly dark body in the solar system. It's got a heavily cratered surface. There's one particularly large crater that probably almost resulted in the destruction of the moon. You'll notice all these striations, which may very well be cracks on the surface of the moon that resulted from this giant impact crater. There's a crater chain visible over here. Here's Phobos. It's one of my favorite photographs taken of Mars. So one of the orbiting spacecraft looked sideways and it snapped this photo of Phobos with Mars in the background. Just a spectacular view of the surface of Mars with that dark Phobos in the foreground. Phobos is large enough to cast shadows on the surface of Mars, so there are some photographs of the shadow on Mars, but it's not quite big enough to cover the sun. So on Mars, you can get an annular eclipse, but you can't get a total solar eclipse. And then Deimos is like Phobos, probably a captured asteroid, captured from the asteroid belt. But we don't know that for sure. And at some point in our exploration of Mars, we will probably actually land on either Phobos and or Deimos and take some samples and bring them back to Earth to determine whether they really are captured asteroids or whether they somehow formed in orbit around Mars. So both of them are irregular in shape. You'll notice that neither of them were round, and that's because small bodies, their surface gravity is weak enough that they cannot crush and break the rocks like you can on the Earth to make the body spherical. Bodies become spherical when their gravity gets strong enough that really tall mountains can exist. Right? You can imagine, think about what we'd mentioned earlier in this lecture about what's happening with Mauna Loa. Mauna Loa has grown so big that its weight is now bending the crust of the Earth. And what that means is that you can't have, when you have surface gravity as strong as gravity here on the Earth, you can't have really irregularly shaped bodies because you can't, imagine Earth, you can't have a really tall bump on Earth because the weight of that bump will actually deform the crust. And it'll actually crush and break the rocks below it and deform the planet until that heavy body comes more to an equilibrium again. And that means that really large planets with lots of mass tend to form themselves in a spherical shape. But small bodies are very often irregular in shape, and that's because their gravity is not strong enough to crush and break rocks. Their gravity is so weak that you can have something that's very irregularly shaped. Okay. And as I've already mentioned, Phobos and Deimos are probably captured asteroids. Phobos, which you'll remember goes around Mars in about 8 hours, actually rotates around Mars faster than Mars rotates. It revolves around Mars in 8 hours. So it goes faster than Mars rotates. And that means it rises in the west and sets in the east every day because it's orbiting faster than the planet rotates. Tidal forces are pulling on Phobos, and Phobos is slowly inching closer and closer to Mars. In about 100 million years, it will either crash to the surface of Mars, or the tidal forces will actually tear Phobos apart, and Mars will end up with a beautiful ring system, just like Saturn. So that is Mars and its two moons, Phobos and Deimos. In our next lecture, we will talk about some, not all, but some of the missions that have explored Mars in the past and in exploring Mars today.